video on explaining the histology and anatomy of heart. Basically, let's not waste time and get into our subject. So, as we know, we are learning about the heart. Now, it is very important for us to understand that for a good sequence, we need to understand the histology in the first order, then the anatomy in the second order. Now, pathology is something that truly is a choice. Like if you have learned anatomy and then you're wanting to learn pathological anatomy or pathmorpho in easy language, it's your choice. Or after anatomy, it's better you get into physiology, and then we come to pathology. So I can say 1, 2, 3, and 4. So let's begin with our topic of histology. I know this is something weird that I'm speaking about the chambers of heart in histology part, but honestly speaking, I've been training students, and some students find very difficult to understand that human heart has got 4 chambers and not 5 chambers, or 6 chambers for that sake. See, we need to understand that there are 4 chambers in our heart, and we have 2 set of chambers that are called as atriums, and 2 sets of chambers that are called as ventricle. Now the set here refers to a pair. There are 2 in number: the right atrium and the left atrium, the right ventricle and the left ventricle. Now we understand, now we know that there are 4 chambers of heart, that is right atrium, right ventricle, left atrium and left ventricle. Now how do we say them in Latin? In Latin we just have atrium dextrum, then we have ventriculus dexter, and we have atrium sinistrum, and then we have ventriculus sinister, right? So they are short forms for what we learn in Latin. We will definitely be mentioning it in the notes, and the link to the notes will be given in the description. So the 4 chambers of the heart are a right atrium, right ventricle, left atrium and left ventricle. Continuing with our topic, we need to understand that the flow to the blood is easily modulated in place, and it's kept in place because of valves. And the valves that are important for us to know are the valves that let blood from the right atrium into the right ventricle, from the left atrium into the left ventricle, and together from both the ventricles individually into respective blood vessels. Now let's say if we have left ventricle, it would be, the vessel living will be aorta. If we speak about the right ventricle, it would be the pulmonary trunk. So there are 4 valves that are interesting for us. Let's say we have the tricuspid valve, the bicuspid valve, and 2 semilunar valves, right? Semilunar, for the name, it's a crescent shape of the cusp of the semilunar valve, which gives the name semilunar valve. Now there are 3 in number for the case of counting. So the tricuspid valve, tricuspid means it has got 3 cusps, bicuspid means it has got 2 cusps, and semilunar valve because of the semilunar shape of the cusp. Now where is where is the tricuspid valve located? The tricuspid valve is located in the right portion of the heart, that is, it's the right atrioventricular valve, the tricuspid valve. Now let's say, where is the bicuspid valve located? The bicuspid valve is located in the left atrioventricular region. The left atrioventricular valve is known as the bicuspid valve, and the bicuspid valve is also known as mitral valve. Mitral valve. Yes. So, and the semilunar valves guard the section of the vessels that leave the ventricles, that is the aorta and pulmonary trunk, is guarded by the semilunar valves. Now, if we speak about the histology part of this valves, is that we must understand that there are again layers that need to be considered when we speak about the valves. So cardiac valves have not been innervated and they do not have vessels for their nourishment, right? So they are not innervated and they are not having vessels. Now, from where do they get the innervation from? Then the innervation is given from the Purkinje fibers through the bundle of His. This is the whole set of conduction. But let's say our cardiac valves have got three layers, right? They've got three layers, and these three layers are endothelium, lamina fibrosa, and fibroelastic tissue. Right. So these cardiac valves have got endothelium, lamina fibrosa, and fibroelastic tissue. Now, endothelium, as you guys know from histology, is a surface lining. Lamina fibrosa is centrally located and it has discs of dense collagenous CT. CT means connective tissue. So it has got dense connective tissue, right? And it's collagenous. About the fibroelastic layer, it is present on the thickened edges at the point of contact of valves. So let's understand this. Let's say we have a valve which this is our wall, this is the septum, and the region where the valve gets attached to the wall is usually, and this is a continued part of the cusp. So this region, let's say red color, so this region we will call as the fibroelastic tissue part of the valve, right? So let's go ahead and learn a bit more about something called as the skeleton of heart. So we need to understand that the cardiac skeleton is not something which is made up of bone. Well, here we use skeleton for the meaning of a supporting structure. Right, so cardiac skeleton is the supporting structure or the framework for the heart. Now, how is it made? This is a four-membered fibrous rings of dense, irregular collagenous connective tissue, and it has got elastic fibers and local fibers of cartilage. Right. So, what do we need to remember? It has, let me change the color for you. So we'll remember that we're speaking about cardiac skeleton, right? So let's write it. We need to remember that there are fibrous rings of dense, irregular connective tissue, DICT, right? And they are solid structures, and they support, this is very important, they support the valves. So this is where the cusps attach to. So 4 rings of dense irregular connective tissue that support the valves. This is how we call what? The cardiac skeleton. Right? Yes. So now what do you know about cardiac skeleton? As I said, it's a 4-ring structure. It is made up of dense irregular connective tissue, and it supports the valves. Now let's learn a bit more. The thing here in green over here is the right fibrous ring, right fibrous ring, and remember it gives you the tricuspid valve. I mean, it supports the tricuspid valve. The one here in blue is our left fibrous ring, and it supports the which valve? Mitral valve. And the 2 rings that you are seeing here, one is over here and the other one is over here, right? Now they individually support the pulmonary trunk and the aorta, the pulmonary trunk and the aorta, right? The pulmonary trunk and the aorta. And now when we speak about them in Latin, one thing that you can understand is the structure located here in yellow. It's called the aortal annulus. I'll write it for you. Let's say AROTALANULUS, the aortal annulus, this structure here. And the structure here, let me clear the things. The structure here is called as the pulmonary annulus, right? So what do we know about the skeleton of the heart? The cardiac skeleton comprises of 4 rings. It is made up of dense irregular connective tissue. It is a supporting structure that supports the valves, and we have the right ring supporting the tricuspid valve, the left ring supporting the mitral valve, the aortal annulus supporting the semilunar valve of aorta, and the pulmonary annulus supporting the semilunar valve of the pulmonary trunk. Okay, let's go ahead. Now let's learn layer by layer of the histology of the wall of the heart. Now we all know that the wall of the heart is totally muscle, but yet we have to know that this layer of muscle, which is located over here, right? It is located over here. It's the muscle part is just in between, and you've got a covering outside and inside, right? So how is it called? What are its structures and how is it related? Let's study. It's very easy and we will finish it real quick, right? So let's start from outside. We start with something called as endocardium, right? Endocardium is the structure inside, but on the screen it's towards your right, the extreme right structure. It's your endocardium, that is towards the blood inside the heart, right? Endocardium. Now this is the lining of all the chambers inside your heart, all the heart chambers. The inner layer, which is facing towards the lumen. What is lumen? Lumen is something vacant, right? Like a cavity. Lumen is something which is vacant like a cavity, so it is the inner layer which faces the lumen, and it corresponds to the intima of the vascular wall. What do you mean by vascular? Vascular means the structures that have been the structures that have been passed through the vessels, maybe artery or veins, but it's vascular if they have got vessels. Now, what are the sublayers of endocardium? We have the endothelium, we have the subendothelium, we have the myoelastic layer, right? And we have subendocardium. Do not get confused. It is endothelium of endocardium, and it is subendocardium of endocardium, right? Endothelium of endocardium and subendocardium of endocardium. Now the muscle layer is quite simple. It's just inner muscle, a middle muscle, and outer muscle. Now inner muscle, middle muscle, and outer muscle are just differentiated based on their course. So, let's say we have a heart over here, right? Now the course that I mean is maybe just its graphic representation for you to understand. The maybe the inner muscles have got their course this way, the middle muscles have their course this way, and the outer muscles have got their course this way. That's it, right? So innermost is this, middle is this, and outer is this. So this is the way I had to explain you how is the muscle being differentiated, the myocardium being differentiated. Now let's talk about epicardium. Epicardium is something which is external or which faces the pericardium, the covering of the heart. So we understand that epicardium is the visceral sheet of the serous part of the pericardium, with vessels providing the blood support for the wall, right? Now again we have got three layers in epicardium, just like myocardium, but three different names, and it will be subepicardial layer, right? Subepicardial layer, the subepicardial layer, and then you've got lamina propria, and then you've got mesothelium. I want to speak a bit more about the subepicardial layer, right? The subepicardial layer. This layer is adjacent to which layer? The myocardium layer, right? So a strong layer of loose collagenous connective tissue with significant amount of fat for the reduction of friction and shock absorption is present in this layer, right? And inside there are arteriae coronariae with their branches and coronary sinus with its affluents. What is arteriae coronariae? It is the coronary arteries that supply the blood to the tissue of the heart, that is to the muscles of the heart, that is found where? It is found in the junction between epicardium and myocardium. Again, the coronary arteries are found where? In the junction of the epicardium and myocardium, in the subepicardial layer of the epicardium, right? Then as I told you, we have lamina propria and we've got mesothelium.